or the by taking the second LOT, by taking AI or LOT, right? So AI is nothing but how we are implementing this AI in our products is, so while building this product, when it goes to the lab, so we have an order to build 10 systems. A system consists of chambers, gas panels, mainframe, and factory interface. So these are the four major modules which consist of a chamber. So we ship the whole unit to the customer so that they can manufacture the chip according to their customizing requirement. So I mainly work on the chambers. So where the process happens, where the wafers are being prepared. So all these supporting common solution groups like factory interface or gas panel or mainframe. These are supporting guys for the mainframe, where supporting guys in the sense all it's just a cover for the robots. So robots come across, take the wafers, empty wafers, and send it to the chamber. All these are not there is no human reference inside this. So everything is done by the robot. So the factory interface, what I referred to, so inside the factory interface, there would be robots, two robots, sometimes four robots, which would try to push the wafer from one chamber to another chamber with respect to the process needs. So mainframe again, it's a chassis. It's a chassis for the chamber or the system. So it acts as a stand base for the system, which catches, which holds the whole process related modules. And chamber is where your process has been done, and the gas panel. So I I work on the chamber, and the gases, whatever. So the gas panel, sometimes it consists of 21 sticks. The maximum sticks we have in our organization is 21 sticks. So the sticks means there are 21 different types of gas which should be sent to the chamber for the process. So sometimes there are even seven, but the overall gases which we send to the chamber is around like 21 on the total. So again, all these consist of a system. When you take the how we are kind of doing this into how we are switching into smart manufacturing is, while it goes to the lab nowadays, the AR VR. So this is helping a lot to the MEs. So what we do is we feed the design, we feed the assembly designs to the software, which in turn the VR engineer or the VR team would try to command accordingly, telling the technician what has to be done. I think you guys have kind of overcome some of them, maybe some VR lab or something, right? So the instruction would be fed in the VR glasses so that once the technician tries to get into the software of that VR, so he will know like what has to be installed, what are the tools required to install, what are the torque or the spec need to be maintained. So all these come under VR things. So this is one of the smart manufacturing which applied is following. This one got implemented, I think, before our corona, maybe roughly 5 years before. So we have a bigger team in India, in US, as well as in Singapore, the VR team. So they do all these stuff for the respective engineers and the technicians. And the next one is the feeding. As I told you, the feeding. So we what the NPME does is we pull the raw design from the designers. So I told you, right, the continuous improvement process in volume manufacturing. So when we get this raw design from the DE, it would be bits and pieces. So all the piece parts would be combined into one assembly, and this one assembly will be having a bigger assembly called kittings. So what we do is again, these assemblies are divided into two. One is make part and buy part. Make part is the assembly which is being bench built in the manufacturing by applied itself. Buy part is the assembly where we purchase it from the suppliers. Again, supplier, all those chain manufacturing process, you guys know, right? So suppliers, in the sense, there are tier 1, tier 2 suppliers. Tier 1, we always go with the tier 1 suppliers, and after that the coating comes, all the planning team, all the engineering team comes on, and they will be working on all those things. So I just wanted to touch with all the department, but since the topic is only with respect to manufacturing, I'll try to elaborate on the manufacturing instead of touching with all the other departments, other stakeholders. So by pulling this, VR is done, and by after VR, we are feeding this design to the VR, and we also have this team called OMS team, so operation method sheet team. So what we do is we give the instruction to the technicians in the Singapore or in US. We show them the breakup of the assemblies. We show them the required spec of a particular module. We tell them what is the torque to be used, what are the hardwares to be used. All these will be fed in the OMS, all these information. And this OMS mapping will be done by the MEs whoever sit in Singapore and in the US. So what they do is they gradually run this mapping. So while running this mapping, if at all they find some errors, they will rectify that error. And once it's 100% completed, that will be forward to the technician, and technician will start referring that. That is again kind of automated. So it will be running in a bigger picture in the manufacturing unit in the lab. So they're looking at that, they would be updating each and everything. So one bigger challenge in semi organizations are the configuration of these assemblies. I told you, like make part or buy part or the kitting, right? The configurations are so higher that each and every customer would require different things. For example, it may come with the hardware, it may come with the washer as well. So some of the companies rely on these o-rings, washers, with certain suppliers alone, in order to maintain, whenever there is a maintenance stuff or whenever there is a problem which they have overcome. So they just refer some of the suppliers where we have to use those o-rings. So the configuration for each and every chamber is would be very vast, it would be very different. So that is the biggest challenge what we are overcoming. So uh, basically, if you compare the semi domain with your automotive domain, right? So the configurations would be fixed, the bomb would be fixed. So you take one product. So once before releasing, you just tell this is our product, this is everything done, this is 100% completed. You release it to the market, and the manufacturing would be the same. So you are building the same machine, same vehicle again and again and again. So they the manufacturing done over there is easy, whereas in semi domain it's not the same. So each and every customer requirement would be different. Each and every, even though it is volume manufacturing, the difference between one particular system which is of same BU would be very much different. Suppose if the same chamber and say same BU is being shipped to another customer. So as I told you, the customization and the churns between two of the chambers, which is shipped to Toshiba and which is going to be shipped to Samsung, would be completely different. At least the delta would be like 50% between these two. So pulling the bomb, like completing the bomb 100% for a particular customer is a bigger task. But this smart manufacturing is helping us so much that we have built so many software, so many tools internally, which helps us to track things so easily. And we would make sure that but whenever it is volume, right, we would make sure that a particular chamber is built within 2 days. Worst case is 2 days. So usually we build a chamber within 1.5 day, but sometimes when there is a backlog of any spare parts, backlog of anything like the OMS is not updated, or some of the new OMSs or new CIPs are not fed into your VR. So so all these things should be overcome by point 0.5 day. So if this is not been done, if the bomb is not 100% completed, if your IOMS is not 100% mapped, right? So the inventory would be filled with all these systems, which is yet to have those backlogs. So again, the fab would be minimal with respect to your particular business unit. So maybe you can build at a time 10 chambers. Suppose if one chamber is blocked or due to some issue, and you are waiting for the part, or you are waiting for your process to be updated, you are waiting for a particular engineer. So that is a backlog. So that one will stand over there. So they will push it over there, and once it gets piled up, right, if the inventory gets piled up, the manufacturing, the you can't build the current system nor the upcoming system. So applied is done a very good job over there, so they maintain so well that immediately there would be some or the other MEs who will be supporting or updating the OMS or all those backup things. But again, even though we tell it is AI, it is robotics, it is without human intervention, we can't even run accordingly. So definitely there is human interaction needed whenever there is process, or even in AI, in VR. So definitely human interventions are needed. So that is one thing I want to tell. And yeah, Sunil, can you go to, yeah. So, big data analyst, as I told you, the bill of materials is one of the big things, key thing which we are overcoming each day. So, this bill of materials, again, we have this engineering bomb, manufacturing bomb, but apply refers overall as a single master bomb. Single master bombs are kind of quotable bombs. So, they even pull this single master bomb as a kind of coating bomb. So sometimes there, I will just tell you one example, like how the bomb works. So there is this retrofit bomb on the other end. So sometimes a customer, we have shipped many systems to a customer, say Samsung. So and Samsung comes back and tells us your chamber was working fine for 1 year, and now we want some more efficiency, some more throughputs for the fab or whatever process it's been done. So at that time, what we do is we send this retrofit. For example, suppose there is this heater. So we have a heater, and Samsung asks us for more eating up in the process. So at that time, what we do is we give this retrofit. Retrofit is nothing but whatever parts present in that particular. Definitely, we can pull the old data what we have shipped to Samsung. So we just see the delta for the new part with the old part, and whatever can be retained will be retained in the old system, and we would just give the delta alone, and we will send the technician to meet with the Samsung technician, and he will explain him what to do, and accordingly the Samsung the customer engineer will update the system. So this is one of the thing which we follow. So data is kind of bigger compared with anything. So without data, we can't pull the history, or we can't give the future. So smart. One of the key point is the data. Sunil, next slide. Yeah. So again, as I told you, AI driven. So we have FI with all the robots. So now we have the new software called Mayan. So the overall, once the installation is done in the manufacturing unit in the lab, right? So this particular chamber will go to the system level integration or system check. So at this system check, there is one coded software which we use called Mayan. So what Mayan does is it will check all your chamber modules one by one. And suppose there is any leak or anything, any problem related, so it will just stop until and unless a technician comes back, see what is the problem, checks the particular module, checks the particular module's electrical line, water line, gas lines. If there is any leak or anything, it doesn't run forward. After that, after resolving the issue, it will go. So it is kind of automated, the coded software called Mayan. So this one would be done in the final testing, final integration and final testing, FIFT. So that is one. And coming to the automation and robots, as I told you, the FI is a robotic one. And we also have some of the automated robots inside the process, inside the main monolith, so that passing the, it may be the passing the wafers, or it may be some of the AI things, safety locks. So uh, so I told you, right, in the gas panel there are 21 sticks. There are safety check locks where you can't send two gases at a time. If you send two gases, the process is going to fail. So all these safety locks are kind of robots which is being used internally inside the chamber, inside the machine, so that it makes sure. And there are also some of the deadly gas being sent, saline, TIOS, some of the vapor gases, some of the liquid gases and all. So all these uh, the EMO switches, all these comes under these robots. So yeah, it's part of our chamber and systems, which is very much helpful today. Okay. Smart material engineering. Yeah, again, smart material. See, applied. What it does is many materials is being pulled from the supplier end. So what applied does is applied just builds all the it just builds the chamber, it's just build the system, but we don't manufacture the wafers, or we don't manufacture the chips. So we just build the machines which manufacture the chambers, and we have very good relationship with all our tier one suppliers, where we get all these ceramic related o-ring, or it may be the eaters, which is a bigger one, which is the art of the process. So materials play a vital role in semi domain. So so this is again digitization. So now in the design itself, what we do is nowadays we are not using our 2D drawings in many cases. So we are using our 3D model itself, which will show up all your constraints with digital. So we we have inbuilt almost all tool capabilities inside this, so that which will show you in depth uh, uh, in depth information of a particular piece part, or it may be a assembly, the by assembly, or the kit. So that is one thing. And sustainability, yes, there is a, we internally have some of the teams called sustainability teams, Ecoya team, which is cost cutting team. Sustainability, we make sure, like especially for the volume products, like what sustain, like suppose we are wasting water in cleaning up after each and every process, like how better we can be sustainable at that. So the engineers are working on all those things. So yes, it's been kind of integrated with our process chain. So how this smart manufacturing is kind of uh, kind of like integrated with applied. So these are some of the checks which we are kind of uh, updated, like accelerating time to market, streamline end-to-end process, quality by design from lab to pilot to plant. So all these are day-to-day process which we are kind of following and overcoming this one. So smart process, it definitely there is an increase in yield, right? So if you have a solution for the problem which you face in the lab, definitely the production would be higher. So and we are also kind of reducing this. We are seeing the reduction of all these rejected or the problematic stuff getting over. So next slide. So yeah, that this is one of the slide which I explained you before. So when there is a problem in particular chamber, it gets the inventory gets higher. So we will make sure that immediately there is one team which will come over, which will see what is the problem, which will update problem accordingly. It may be the process problem or the material problem or the people problem. So smart scheduling is again the planning session. So the planner does it very well accordingly, because we have region to region. Again, our build is done in US two places. One is in Santa Clara and other one is in Austin, and we do all our volume in Singapore. So smart scheduling is one of the main thing which is being considered, because with respect to the customer, sometimes we will plan to obsolete a particular platform, the whole product itself, the whole product line itself, we will try to obsolete it. But some of the old customers, tier one customers like TSMC or Intel or Samsung, they would again be wanting back the old product rather than the new one. So what they do is they just again ask us to activate the inactive product. So we have a process in place for all those scheduling activities that is being taken care, and these are the advantages by doing all those things. This, yeah, next slide, please. Yeah, smart inspection. So there are many internal teams which have peers for each and everything. You take design, you take NPME quality, you take OMS quality, you take master layout quality, or the ME's mapping quality. So everything has kind of been forwarding. Once the work is done, it's been done by a peer as well. It's been quality checked, and there is this Mayan tool as well, so which would rather catch at the last. Suppose if there is anything, any defects or anything happening, or any checks or loose fittings or anything being done. So yeah, so by doing all the smart inspection, these are the advantage. And coming to the real world versus smart manufacturing. So uh, so when you kind of compare with the automotive industries, so definitely the production is going to increase, and the tracking supply chain, which makes help you to find the history or the tracking of the piece parts, or a part which where you get almost like 10,000 1 lakh parts involved in a particular product. So yeah, that is one of the thing. Coming to electronics, the sensor quality control, 3D printer, and for pharmaceuticals, AI driven drugs. So all these, even I forgot to add one more point, that is on the chemical side. So on the gases, as I told you, like what are the gases and all these things. So definitely the smart manufacturing is our newer thing for all the manufacturing, for all the OEMs going forward. Yeah, these are some of the added points for the respective department, for the respective domains. So if you take in aerospace, what are the What are the things like consumer goods, textile, construction, energy, etc.? Yeah, the challenges are definitely the high investment, what is going on, and the period, especially the period, because it's not that once you implement the smart factoring, everything will be running fine, everything will be automated. No. So the testing process itself will take like couple of years, and corrections like where exactly, whether it's rightly used. So definitely the time and the investment would be higher. Cybersecurity risk, yes. And integration with legacy system, yes, this is easier comparatively. When you touch up with other key points, this is bit okay. And skill gap is fine. Skill gap, again, the skilled experienced technician or related manufacturing engineers. And data privacy is one of the main thing which is very much needed in all our semi tool organizations. So case study, this one I pulled in one of the journals. So this is kind of GE has done a digital twin technology in enhanced predictive maintenance. So I just bought some of the uh, I points, highlighted some of them. So just to showcase for the audience. Yeah, next slide. Sunil. The future of smart manufacturing, exactly like whatever we have come across, right? So expansion of AI and machinery, as I told you, yes, AI would rule the world going forward, and greater adoption of argument. Yeah, the VR, as I told you. So VR, there are less amount of uh, yeah, problem happening to the humans instead. So the VR is one of the thing, and the risk of warehouse logistics, yes. Raise of warehouse and logistics, yes. Integration of blockchain and improve transparency and traceability, yes. The data thing. So this will become the future of all smart manufacturing. So the conclusion, to say, so India, I would conclude in this way rather than saying like we have smart manufacturing getting implemented in automotives and some of the electrical car manufacturings. But when it comes to semi, we are not still there, especially India. But slowly we are knocking the doors. Yes.
Anybody having queries, kindly interact with the session expert, Raja sir.
Sir,
Yeah, yeah, Sunil.
sir, can you elaborate in what domains your company is into?
Yeah, so as I told you, Sunil, we are completely into semiconductors. We are semi-domain. So when you take semi-domain, right? So applied materials, LAM, and ASM and ASML. So these are the three bigger companies. What they do is we build the systems which manufactures the chips. So we don't manufacture chips. So chips have been manufactured by Apple, Samsung, Toshiba, TSMC, Tokyo Electron, all these customers. We don't manufacture chips. We just sell our machines who manufacture chips. Not only we, our competitors are LAM and ASM. And there are some companies like TSMC. So TSMC, Micron, they are very bigger, but they do both. They do the manufacturing. They also sell some of their systems to the customers, and they are also applied customer where they also buy our systems and they sell it to the customer. They do some modification, they do updates on our systems, and they again forward it to the related customer, whoever they require. Have I answered your question, Sunil? So basically, note is we are not manufacturing any chips or any wafers. Applied is not manufacturing.
Yes, sir. Thank you.
Sir, Hemant, sir.
Hello, sir.
Hello?
Yeah.
Yes.
Hello,
Yes,
sir.
sir.
Sir, Raja, sir, there is one more question from the participant. So that is posted in chat box.
Okay.
Yeah. Can you suggest some real life examples of piezoelectric crystal in smart manufacturing? What is the research scope in field of piezoelectric sensor, sir? So that is a question.
Can I get back to you later on this question, sir? I think I have to look into this. We have not overcome
Okay,
such,
sir.
but yeah.
Okay, sir. Okay, sir. Fine, sir. I'll convey the same thing to the participant, sir.
Yeah, definitely. Sorry, Sunil, can you just list out the questions and mail me so that I would be happy to answer them back.
Yes, sir. Sure,
Maybe
sir.
by tomorrow or by this weekend, for sure.
Sure, sir.
Yeah.
We will collect these questions and we will send to you. Then reply
Yeah.
back, the answer will be shared to the respective participant.
Yeah, sure, sir, sure. Yeah, that can be done.
Any other questions from the participants?
Sir, please read out the chat box questions.
Yeah, sir. Sir, and there is one more question. Sir, how smart inspection is different from inspection, and in which sectors smart inspections can be applied?
So smart inspection. So when you take, so now we are not kind of integrating the smart manufacturing into organization. So what we do is we don't use some of the tools like Mayan and other things. So previously, maybe past 5 years before, or 5 years before or 6 years before, right? So everything was done by another machine. Means we used to check the leak in our chambers. We used to check other things without any software, any tools, and it would be done with the help of humans. But now this Mayan software, which makes sure that suppose if in with humans there are chances of skipping one or two checks, if he's a new guy or if he's not that much skilled or if he's non-experienced. So again, there is a experienced guy who has to come back and do a peer check for all these system which is being ready to be shipped shortly. But your tools, some of the AI tools like Mayan, what it does is it makes sure that suppose if there is a problem in a particular module or somewhere in the mid of your check, it will stop or it will never allow you to move forward. So these are the things which is kind of involved in smart manufacturing. I would say, yeah.
Yes, sir.
Some of the
Thank you,
tools.
sir. Thank you very much, sir. And there is one more question, sir.
Mhm.
Can you elaborate on how digital twins helps in eliminating drawings, sir? There is one more question from the participant, sir. Please.
Yes. So first of all, the before the 2D drawings, whatever we add from our tool, so 2D. So the experienced guy would easily find the problems or the errors in a drawing sheet. Whereas when it comes to the 3D model, which would give you the dimensions, which would give you the details, or your GD&T in your 3D model itself. So that is very clear to everyone, so that you can just rotate your stuff and you can just detail it like whatever it is. So I think that is one of the futuristic tool we which is helping us, right? Especially the manufacturing or the mechanical engineers. So regarding the twin, I think I will I will reply to that question, sir. Whatever the question is, maybe I can elaborate through my mail.
Okay, sir.
Yeah.
Yes, sir. Yes, sir. Thank you, sir. Thank you very much, sir. Any other questions from the participants? Please let me know. So there is a last question, sir. Yeah, sir. Do you think that we have been fully utilizing Industry 4.0 tools in smart manufacturing today? What level do you think we are? Are the industries in India practicing 15.0 also? So there's a question from Dr. Sudhit, sir.
No, sir. As per me, I really don't know what is happening in ISRO, but when it comes to semi-domain, as per India, we still don't have that capability where our prime minister is moving towards it. So to say the fact, we applied, even tried to build some of the semi tool, like uh, this semi tool will help the chambers which we are building in US or Singapore. For example, faceplate coating or all those tools we try to set up in India, but the main challenge is the supplier. So all these semi tools, right? So they require like it should be dust free particles, but we don't have that capability from our supplier end inside India. So again, if you go importing from the other country suppliers, again the time is a bigger challenge. So we are not there, but we will be there. Maybe as per our Modi say, like 2026, we'll be producing the first chip, and I think that is from Tata. So yeah, hope for the best.
Thank you, sir. Thank you so much.
Yeah, thank you, sir. Thank you very much. Hello, everyone. This is Dr. Hemant Raju. On behalf of New Horizon Management, Principal, Dean, Director, HOD, and faculties, I thank the speaker, Mr. Raja Nataraja, sir, for taking his time on transferring the knowledge on the topic smart manufacturing. It's a great learning for all of us. Thank you very much, sir. I also thank ACT Atal for giving us opportunity for conducting this program. Thank you all participants for joining the session. And I will be posting the feedback link and the quiz link for this session too. I request all of you to fill the link, and the link will be activated for 20 minutes. I request all of you to kindly complete it well within the time. So thank you one and all for this session.
So 1 minute. Thank you, sir. Tomorrow we have 2 sessions. Evening 6 p.m. the third session will be given by Dr. Piyush Kumar Soni, Professor and Associate Head, IAE, New Horizon College of Engineering, Bangalore, in the topic of integrating IoT in production processes. And continue that, the fourth session will be given this expert, Mr. Rohit Tyag Arasu, Deputy Manager, Vodafone, Bengaluru, in the topic of data analytics in manufacturing, from data to insights. So we are having the 2 sessions on tomorrow. It will be started at 6 p.m. exactly. So I request all the participants kindly join the tomorrow sessions at 6 p.m. Thank you, one and all.